Okay, everybody, we are going to factor quadratics using the AC method. The more mathematical terminology for that would be to say we're going to factor by grouping. But quote unquote, the AC method seems to be what everybody calls this. So I have both terminologies down here for you. Well, I have this quadratic, 6x squared minus 7x plus 2, and I'm going to factor this thing. The first thing I'm going to do is look to see if I have any common factors throughout the quadratic, and it doesn't appear as though I do. So I'm now going to take this 6x squared, push it over just a little bit. I'm going to take the plus 2, push that over a little bit, and I'm going to go to the side, and I'm going to see if I can replace that negative 7x squared with a couple of terms that are going to make this thing easily factorable. So I'm going to do this AC idea with you guys, which means I'm going to make this x right here. And basically, I want to find two numbers that are going to multiply to make AC and combine to equal B. Now, I hope we all know that we're looking at ax squared plus bx plus c, just like we would use for the quadratic formula. Okay, that being said, if I did this little AC method here, I multiply my 6 by my 2, and that gives me a positive 12. So this AC right here can be replaced with a positive 12. My b is the coefficient of my middle term, my linear term, and that's a negative 7. So I'm looking for two numbers that multiply to make a positive 12, and when you combine them, you get negative 7. You can play around a little bit, but you're going to find those numbers to be a negative 4 and a negative 3. Negative 4 multiplied by negative 3 makes a positive 12. That checks. Negative 4 combined with negative 3 make negative 7, so that checks as well. So the negative 4 and the negative 3 actually have to have x's shoved on them like this, because those are really just the coefficients of my middle term. So I'm going to take the negative 4x and the negative 3x, and I am going to put them into my equation here in place of the negative 7x. So what happens is I've actually found the two middle terms of my FOIL process that were combined together to make the negative 7x. Okay, and here was where we factor by grouping. We put a little squiggly under the first two terms and we ask ourselves what's common between 6x squared and a negative 4x. And I hope everybody can figure out that there's a 2x common between those two terms. You factor a 2x out and you're automatically left with 3x minus 2. At this point, you simply push over a little bit, leave a little bit of a space, and copy the 3x minus 2 inside your parentheses again. You are guaranteed to get that factor twice if you were capable of finding the two numbers in your AC method. So now you ask yourself, what needs to be factored out of negative 3x plus 2 to create something times 3x minus 2? And hopefully everybody can see that's a negative 1. Multiply that back out and make sure that it checks, okay? Negative 1 times 3x does indeed give me the negative 3x, and a negative 1 times a negative 2 does indeed give me a positive 2. So that does work. Now I have a 3x minus 2 and a 3x minus 2 common in both of these terms. I'm going to factor out a 3x minus 2, and when I factor out that 3x minus 2, I simply look at the coefficients that are in front of the 3x minus 2 to create my other binomial, and that makes 2x minus 1. So if I wanted to factor 6x squared minus 7x plus 2, those factors are 3x minus 2 multiplied by 2x minus 1. That would be the answer to my question to how I would factor. Now some of you might ask, well, how did you know to put the negative 4x before the negative 3x? And I'm going to show you that it really doesn't matter. So I'm going to start with my 6x squared again, but instead of putting minus 4x minus 3x, I'm going to go backwards and I'm going to say minus 3x minus 4x, and still a plus 2 on the end. Draw my little squiggly. What's common with 6x squared and negative 3x? I'm hoping you think 3x. This gives me 2x minus 1. I push over and I write 2x minus 1 again. And I ask myself, what number has to go right here in order to multiply by 2x minus 1 and get the negative 4x plus 2 that's right above it? So I'm hoping everybody comes up with the fact that that has to be a minus 2. Double check it. Negative 2 times 2x does indeed give you negative 4x, and negative 2 times a negative 1 does indeed give you a positive 2. I now have a 2x minus 1 common. Factor out a 2x minus 1, And the other factor that you're going to get is going to be comprised of the coefficients on those two factors that we pulled out, and we end up with 3x minus 2 here. That's the same exact answer as I had originally. 6x squared minus 7x plus 2 is now equal to 2x minus 1 multiplied by 3x minus 2. Same answer I boxed up above. Same thing either way. Okay, one more example on factoring by grouping. So let me create one more here. We'll call this example 2. Let's get this thing separated. Okay, here's example 2. Let's say, for instance, I gave you 8x squared. Let me see, the directions are going to say, of course, factor 8x squared minus 14x minus 15. Okay, there's no common factors here, so I don't have to worry about pulling out a common factor. Let's just jump right to that AC method here over to the side. I'm looking for two numbers that multiply to equal AC. 8 times a negative 15 is a negative 120, goes up on top. The negative 14 from my B goes down here. And I am looking for two numbers that when you multiply them together, you get negative 120. When you combine them, you get negative 14. Hopefully you understand that the signs have to be different in order to create a negative 120. So you're going to play around a little bit. I tried 12 times 10. That didn't work. I tried 20 times 6. Oh, you know what? I think 20 times 6 is going to work here. 20 times 6. If I multiply 20 times 6, I get 120, and if I subtract them, I get 14. So if I put the 20 to be negative and I put the 6 to be positive here, I think that works. Negative 20 times a positive 6 will indeed make a negative 120. That checks. And a negative 20 combined with a positive 6 makes negative 14. That checks. Good. So I'm just going to throw x's right here, and I am going to rewrite my function, my quadratic, as 8x squared, and in place of the negative 14x, I'm going to call this negative 20x plus 6x, and then I'm just going to copy the minus 15. Squiggly under the first two, what's common between 8x squared and minus 20x? There's a 4x common there, leaving me with 2x minus 5. Simply push over, write another 2x minus 5, and ask yourself what has to go here so that when I multiply it through by 2x minus 5, I get the positive 6x minus 15. So I know that 2 times 3 makes 6x if I use a positive 3, and that would check because a positive 3 times a negative 5 does indeed give you the negative 15 above. All right, so I have a 2x minus 5 here and a 2x minus 5 here. I will factor out the 2x minus 5. I am left with 4x plus 3 in my other set of parentheses. So therefore, my original quadratic, 8x squared minus 14x minus 15, is now equal to 2x minus 5 multiplied by 4x plus 3. This is a final good answer. And we have factored by grouping. Let's take those same factors. Let's take the same quadratic anyway. 8x squared minus 14x minus 15. And instead of putting down my factors, sorry, not my factors, but instead of splitting up negative 14x into negative 20x plus 6x, let's split this up into a positive 6x minus 20x. We'll copy the 8x squared. We'll copy the 15. We will factor by grouping and show that we get the same exact thing. So what's common with 8x squared and 6x? Definitely a 2x out of that deal, leaving me with a 4x plus 3. Simply push over and write 4x plus 3 one more time and ask yourself what must go here so that when I multiply it through a 4x plus 3, I get what's above, which is a negative 20x minus 15. And that answer is negative 5. I now take the 4x plus 3 that I see in both terms and I write it once, 4x plus 3. I create my other factor simply by grabbing this 2x minus 5, and I get the same factors I had before. Of course, I get them in reverse order, and that's okay. So 8x squared minus 14x minus 5 is indeed equal to 4x plus 3 multiplied by 2x minus 5. And that wraps up. These are absolutely identical to each other. They're in reverse order, but multiplication is commutative, so it doesn't matter if you're multiplying a times b or b times a, you get the same product. Okay, I hope this helps you. You had a couple of examples for factoring quadratics using your AC method, and we are done. So therefore, let's sign out here with talent out.